Okay, good morning and good afternoon and good evening as well to some. So welcome to today's IDSA Tech Talk. And today we will be exploring the IDS Information Model in more detail, and which is a crucial part of the IDS framework. And so we will go deep into details of how it secures the semantic interoperability. So we have Johannes today with us, Johannes Lieb from Fraunhofer FITS, and to go deeper into details with that. And as usual, our Tech Talk is being powered by some projects, so including BD4 Energy, Databricks, Divine, Enershare, Dacapo, Fame, OmegaX, Datamite, and ViroSwarm. And so, Johannes, I would like to invite you to the stage to go ahead.
Thank you very much. Okay, so I hope that you can see my presentation screen. So yeah, welcome also from my side to today's Tech Talk on the IDS Information Model and on a way to achieve semantic interoperability. Let me first introduce myself. So my name is Johannes. I'm the Deputy Team Lead for the Data Management Team of the Data Science and AI Department at Fraunhofer FIT. Fraunhofer FIT is researching on applied information technology, and we are involved in the IDS on the information model. Is the International Data Space Information Model. I think most of you have already worked with the information model, but we will go into detail today. We as Fraunhofer FIT, me and my colleagues, we are also involved in other data spaces projects, which includes, for example, the European Gaia-X project, which is also in many parts strongly interconnected with the IDS. And on my in my second affiliation, I'm researching on the Aachen University. I'm just doing in the final phase of my PhD, researching on semantic foundations of data spaces. So let me first start my presentation on a quick motivation, like why do we even need interoperability? Why do we even need a information model? And I would start with a slide from Pierre. He's the CTO of Gaia-X, and he just presented this a few weeks ago. So the core idea of like how to build a data space requires multiple parts. So this starts with some governance that can be operationalized, and then we additionally need some infrastructure that we can operate on, which adopts this governance, like how do we communicate with each other, and so on and so forth. And then last but not least, we need parties. In the IDS, this is often called participants. So we need someone who acts on the infrastructure, adopting this governance. And we can then use all these techniques that work together with each other to finally access data in a fair, transparent, and non-discriminatory manner. And this is a very, very, very good goal, a very important goal to achieve. And this is also supported by, this is the citation on the slide here, by the SEMIC Support Center for Data Spaces. All these goals or these building blocks come with problems, opportunities, or challenges. So first of all, obviously, there's lots of data out there in the world already, and there's lots of communication, not only on the internet, but also in other communication ways out there. And some of these interconnections can be named data spaces, but they are not really discoverable, the data in there. And the communication does not work properly, to be honest. So Pierre highlighted in his talk just recently that the governance and also the infrastructure interoperability is really, really hard to achieve. Maybe it's even impossible to achieve this. So we will, in today's talk, first tackle the term of interoperability interoperability once more. I am aware of the fact that we covered this in previous tech talks as well, but we will dive a bit deeper in the interoperability and the semantic interoperability section. And we will then have a very precise look at the IDS information model and how all this plays together, and how this supports achieving this goal of semantic interoperability. So yeah, we first start with interoperability or semantic interoperability. So let me at the very beginning distinguish the term syntactic and semantic interoperabilities from each other. So the syntactic interoperability, also called technical interoperability, here the key is that we have very common data formats and communication protocols. So the goal is that communication systems or partners or participants in a data space can communicate with each other in some way. And then the next layer, which is basically on top of that, is the semantic interoperability. This includes that we not only receive information or data from someone else, but we also are able to interpret or understand that information. So this can be also formulated as what is sent is the same as what is understood at the recipient side. And this is also covered in the IDS reference model. So now we have these very foundational terms covered, and we will now have a look into some more definitions on like interoperability or semantic interoperability. I brought 3 of these. So we can interpret this as the ability of entities in a network to connect with each other and to carry out their functions. So you see, we need both syntactic to connect with each other and transform information, but we also need semantic interoperability so that we can actually implement our functions and the with the knowledge and the understanding behind that. Second, this can be interpreted as the characteristic of a product or system to work with other products or systems. So this is basically really similar to the first phrase. And then last, we have the ability of systems to exchange. So again, like syntactic, so we exchange information, but also we make use, we interpret this information in a very useful way. And this part here on this little formula here on the bottom is also something I want to stress on today. This was also highlighted by Pia just recently. So interoperability usually is not a true or false Boolean value. So it's not like, okay, these systems are interoperable and these are not. It's in like 99% of the cases, it's some distance measurement. So of course, when we have like no syntactic interoperability, this distance will be very high. So even when we send a package or some data to a communication partner and they even can't receive the data or can't even load the data, and then the distance is very high. But between that, just like sending data and really interpreting the data, strongly work with each other together, this will result in a very small distance. Of course, there's no formula from the shelf that you can use to calculate this distance, but this is really important to keep in mind that it's not a true or false value, but it comes in different layers, it comes in different measurements, and there's very many things that we need to plug together. So let's now have a look at the layers of interoperability in data spaces. This was presented by Peter, I think, in some previous tech talk as well. So let me just go through this from bottom to top. So in the very basic interoperability layer, we have the technical or the syntactic layer, that's what we had before. This is basically on the question, can communication partners, or in the IDS universe, can connectors somehow communicate with each other? And this is tackled by the IDSA data spaces protocol, which we will cover in the next slides. Then the second layer is the semantic interoperability. That is, do policies and attributes and information that we communicate with each other, do they express the same meaning on both sides, like the sender and the receiver side? This is covered by semantic models. and conceptual models, such as, for example, the IDS Information Model, which we will cover in the second part of today's tech talk. Then we come to the more like higher level of interoperability. This covers the organizational interoperability, which is, for example, covered by the IDSA rulebook. And this tackles the area of like, can business processes or business procedures, are they compatible with each other? Yeah. So even though we like send data and send more additional information like units or metadata along with this, this is not just sufficient, but we have more sophisticated business processes behind the communication and the applications that we use. It is very important that these at some point will also be interoperable with each other. Then even one layer up is the legal interoperability that covers like contractual statements, for example, which are very important in one of the data space's key goal, namely the data sovereignty, and whether these sometimes very complex contractual statements, if they are legally equivalent, this is also covered by the IDSA legal task force, for example. So today we'll only cover the technical and semantic layers. So let me start with the technical layer and introduce the IDSA data space protocol. And after that, we will tackle the semantic layer coming to the IDS Information Model. So the data space protocol is a foundation for the technical interoperability. And this content was presented before by Julia. Sorry for the medium quality of this slide. So the core idea is that we have IDS connectors. These are these blue circles, which connect parties within data space. So for example, here we have a company that interacts with a industrial data cloud, for example. And on both sides, we have these IDS connectors, which implement the data space protocol. So now we ensure that these two can communicate with each other. Now we have this syntactic or technical interoperability, so they can communicate with each other. But now we also have here these small blue letters. That is the data usage constraints. This is semantic information that we add to this communication channel. And by using these common IDS connectors that implement the data space protocol, we ensure that all the communication parties here which join, that they can communicate with each other because they use the same protocol and the same rules to interact with each other. So all the data space communication is here is illustrated by these dotted lines. So we can have multiple partners communicate with each other. And then it is also worth mentioning that we not only have data space communication, but the partners might also have some other form of communications with each other. These are these like straight lines here. For example, company 2 also has some other communication channel with company N, which is no IDS data communication, but maybe email communication or some other communication channels, some other data communication channels that they have. But all these go hand in hand and go and work really well in parallel with each other. Now the data space protocol is not just communication, that's it, but it provides two layers or two planes of communication. So one is this upper one is the control plane that we can use to monitor communication. We can execute contract negotiation here. We can offer data, we can respect identities, configure our communication channels, and so on and so forth. This is a very powerful channel here that we can use. And the second plane is the data plane, which is rather simple, illustrated in the slide. So we have one communication party and another communication party, and then they exchange payload, they exchange data with each other. And it is worth mentioning that these two layers work independently of each other. So we can only implement the control plane, we can only implement the data plane, we can implement both of them, and it's all possible to do so. And this IDS data space protocol is still under very active development, but we're making great progress here. And it's really important to not reinvent the wheel. So there are already a lot of communication protocols out there. There's also a lot of communication protocols out there. So the goal of the data space protocol is not to start from scratch and just define some protocol for others to use, but we want to be also interoperable with other protocols and be easy reusable. So therefore, the IDS data space protocol specification bases on W3C standards. So we reuse as much as possible, which is out there in the world already, because people know all this information, and we do not need to reinvent the wheel, and we are more compatible with other protocols. So here we have the data space protocol, which has different layers, and we, for example, reuse the data catalog vocabulary that implements information on like data catalogs, data sets. We can also, for a data set, we can also define distributions like different file formats, different locations of files, of data, and so on and so forth. And we can also describe services, not only pure data, but also data or other more sophisticated services. This is also a very important detail in Gaia X, because they also not only rely on data, but also focus on data services within the data space. On the other hand, we reuse for contract negotiation and usage policies and data sovereignty in general, we use ODRL. This is short for Open Digital Rights Language, so a language to describe digital rights. And a very brief screenshot is here. So we can describe policies we can attach to data offers. So we can describe our data with DCAT, the data catalog vocabulary, and we can then add policies in terms of offers to the data when we offer these in a catalog or some other source of indexing service. And between two or more communication parties, we can agree on agreements for data usage, data policies, and maybe even payment and monetarization of data. This is all covered in ODRL, and we just link these assets together to make best use of these. And there are two additional things I would like to mention for the IDS data space protocol. That is the step towards global alignment of this protocol and towards interoperability with other protocols and initiatives. So Peter also just recently, or Peter and Sebastian recently mentioned that it's not important just to define a protocol that you use within your data space, because the real world does not work like that. You do not have closed environments and that's it, but we also need intra data space interoperability. This communicate either between multiple IDS data spaces or communicate between like an IDS data space and some other data space, such as Gaia X, EOSC, and so on and so forth. So this not only covers, again, not only covers just the data exchange, but also the semantic interoperability and the other layers that we had before. And how do we achieve this? Here I would like to add some information by Pierre, again from Gaia X. He suggests to use one or more ontologies or conceptual models to cover the governance and the semantic interoperability. And it is also very important for him to leave very small technical footprints. What does this mean? The technical footprints in his point of view is that we introduce new stuff that leaves footprints in the world. So how do we avoid this? We do not reinvent stuff again, but we build on existing standard, we reuse existing and widely used assets as much as possible across all the data space and across all our federation. So this was on the interoperability and the data space protocol. And I will now come to the second part of today's tech talk, that is on the IDS Information Model, which is one asset, one conceptual model to achieve the second layer of interoperability, namely the semantic interoperability. Yeah? So the data space protocol covers the technical level, so the very lower level. Now we come to the semantic level, so the second level of interoperability. The IDS Information Model is published in different representations. So let me just guide you through this illustration from top to bottom. So we do have the IDS reference architecture and other documents that come along with this, which represent conceptual representations of the IDS Information Model. This is published in documents and visual notations like UML diagrams, pictures, README files, and so on and so forth, websites, and so on. This covers a very high analysis and overview and explanation, and really lots of human readable information on all these conceptual approaches that are involved in these. And from these documents, we derive constraints for a declarative representation. This is a rather technical representation of the IDS Information Model, namely an ontology with additional files. So we have a RDF OWL ontology, which is augmented by Sparkle queries. So you can query data from there and filter information. This also comes along with shackled shapes. These are so-called constraints. They can be used for data quality validation, data validation, and constraint and compatibility checking. So when you have an instance of the information model for a data or text resource, for example, you could validate if that instance conforms with the IDS Information Model or not. And from here, of course, when we have in our code repositories on GitHub, we get some feedback there via issues and so on. We also push back this feedback to also improve this conceptual representation in the IDS reference architecture and other documents continuously. And from there, we even have a more specific representation, that is the so-called programmatic representation, which basically is auto-generated code that can be used for integration, tooling, processing, and application development. We have different forms here, but we mainly use Java representation. So a Java CodeGen tool represents Java classes that you can use to generate, process, and communicate IDS Information Model instances. And same here, we incorporate feedback, obviously, to the other layers. So these are the representations of the information model. Let me come to a brief overview of the content of the information model. So the information model covers 6 concerns. So it's content, concepts, community of trust, commodity, communication, and context. And on the right side of the slide, we see this same hexagon of concerns, but with a bit more details. So, for example, for the context of data or participants in a data space, it might be worthwhile to express time details. Like, for example, for a data set, this is data about some details from 2020, for example, and then the spatial information we can store, entity information, and so forth. And this also adds to all the other concerns in this hexagon of concerns. I will not name all these right now, but a very important takeaway message here are these gray boxes. So, for example, for the time, we do not introduce or reinvent terms to describe time, but we reuse the W3C OWL time ontology, which already includes lots of things on how to describe metadata about time or about things. Same for the spatial things. We use this geolocation ontology, WGS84. We just reuse it and integrate it in the information model. Same for the actual content, so the data or the participant. We use, as we had before, like DCAT. We use void. We use data cube. Data cube can be used to describe the inner content of a file. So, for example, when we have an Excel spreadsheet, we can use data cube to describe the rows and columns of that file, of that content of the file. So we can filter based on this content, and then later on just retrieve just the right data that we would like to see. On the conceptual layer, we use SCOS, so this simple knowledge organization scheme to represent things. We use the organization ontology to describe participants, like their names, their address, their contact data, like email and so on and so forth. ODL, this is what we had before. We use DQV for the data quality vocabulary to describe the quality of data and other things. And for example, we use the prof ontology to model provenance to foster data sovereignty. We published a paper on the Semantic Web Conference on the IDS Information Model, which covered or which included this example on a real world example from a fintech company. And I will very briefly guide you through this example right now to understand some of the core ideas of the IDS Information Model. So let's just start on the very top left. So we do have an IDS connector which speaks the IDS data space protocol, so it can communicate with other connectors. But now we need the information model to describe the actual content of the stuff that is being communicated, and that it can be understood at the other side of the end, the communication channel. So this connector, for example, has some identifier. It has some IDS metadata such as maintainer. So for example, here we have some participant who maintains this connector. So this is represented by all these things. And then this connector might have, in this example, has a reference to a IDS resource, which is a catalog of BI products. And this catalog has maybe more lots of resources in it, but one of the resources included in this catalog is a data resource, which is in this example, in this paper, is a data vault to Wall Street 2019. And this data is a data set, and it has multiple representations. And one of these example representations is a CSV file, which is a IDS data representation, which then has an instance, which is a very particular CSV file, which is stored on some hard drive. And that is an IDS artifact. So how do these things now like connect to each other? So the data resource in this example has a contract offer, so a usage offer. So when we offer this data set in a catalog, we add some usage information to this, some usage rules to this. So whoever uses this data needs to respect our usage policies. So the target of this usage offer obviously is the data itself. So we have links to these artifacts. And now some other communication party can send a request message that uses this usage offer and then finally accesses the data itself and then make use of the data. Now in this example, we had all these IDS representation, IDS catalog, and so on here. This is because this is a rather like not really up-to-date image. So in the meanwhile, this was starting from 2021, but we finalized this last year. We substituted all these IDS references with the proper external ontology references. So for example, here, as of today, this will not be IDS catalog anymore, but DCAT catalog, because there is the data catalog vocabulary and we reuse their content. And instead of just copying or just renaming the assets that are defined there, we directly reuse this external and standardized content to again increase interoperability of this model. So as you might have noted, the IDS Information Model is a general purpose vocabulary. So it describes very general things like connectors, data, participants, and so on and so forth. In many application scenarios, it is important to also describe very domain-specific information. As an example from the mobility sector, it might be not sufficient to just filter data based on their geolocation, but maybe on their mode of transport. Like, is this data about buses, cars, bikes, and so on? So in many application scenarios, you want to add domain-specific information and knowledge and semantics into your data space. So this is why also last year, the IDS Information Model introduced domain-specific extensions. And I will start the slide with the right-hand side, this illustration here. So the general idea of these domain-specific extensions is that we have this dark blue box here with all the IDS properties we have in the so all the terms we have in the IDS data space, IDS Information Model. And from these, we selected some core properties which are mandatory and really important to provide basic functionality of the IDS connectors. And then these can be extended with domain-specific properties as you need. And the process for this is that some project or some use case first decides what they would like to model. And then they use the IDS Information Model as a basis, as a baseline for describing the very general concepts. And then they add to the information model, they add local definitions and restrictions from their domain. And ultimately, they can not only then validate if a message that is received at a connector conforms to the IDS Information Model, but they can also validate if the message conforms to the domain-specific extension of this. Like for the mobility sector, for example, we could implement a catalog that only accepts data where the transportation mode, like bus, bike, and so on, is attached to the data. If there's no, then we can warn the user or act in some way that is intended. This is a very powerful way to agree on this common base. So all data space adopters and participants agree on this common core of the IDS Information Model, but then they extend it to their needs in the end, which is a very powerful technique in our point of view. And a very important second thing of this is that we have this common core, because this enables us to be aligned with other data spaces out there. And this is what we also strive for from both sides, as we as Fraunhofer are involved both in the IDS, but also in GaiaX and FAIR data spaces and in other data space projects. So it is very important that we align many data spaces with each other. So on this slide, we cover, as an example, we cover the IDS Information Model and its alignment with the GaiaX self-descriptions. The GaiaX self-descriptions are also is also a conceptual model to describe assets in GaiaX, such as participants, providers, data assets, services, but also more sophisticated things such as resources or data assets. And this is the GaiaX environment here. And in here, we have many things that are on a conceptual layer, very similar to IDS concepts, and that can be integrated with each other. For example, here in a federated catalog, we can have also like IDS brokers, vocabulary providers, and the information model here as semantic model. On the right-hand side in GaiaX, we have the sovereign data exchange which also includes data usage policies, trusted environments, compliance, and so on and so forth. And this is also on a conceptual layer very strongly aligned with the IDS, but on the other layers, honestly, there's still some work to do, but both sides work together with each other and yeah, get more closer to each other to incorporate more all these alignments. Regarding the data exchange itself and the semantic descriptions, actually GaiaX and the IDS are very closely aligned already, both on technical and on semantic layers. But the others, of course, these more like higher levels of interoperability are not ultimately finished already or yet. Just once more, the IDS Information Model and the GaiaX self-descriptions, they are general purpose or very general vocabularies or models, which are a common ground, like a common core for communication, and they are intended to be reused and be extended for domain-specific applications to work best. I will now come to the end of our presentation and do a very brief conclusion of what we discussed about today, or what we spoke about today. So the motivation very briefly was that data space components must work with each other. Components includes the humans, but also the implementations and technical things already. The interoperability is not a Boolean value like true false, but it comes at a distance between two systems or two communication partners. And there are multiple layers of interoperability, which were presented by Peter before, and today we focused on the technical layer that is covered by the IDS data space protocol, and we tackled the semantic layer, which is, for example, covered by the IDS Information Model. And this IDS Information Model also have multiple layers, right? So we have this just PDF files which can be downloaded from the IDSA website, but we also have the ontology files and Java implementations of these. So we have these different layers. The IDS Information Model addresses 6 major concerns, which are these, and we reuse lots of external vocabularies of well-implemented standards and best practices there to be very interoperable with other things. The IDS Information Model is a general purpose model, which, however, can be extended to domain-specific applications. So we have this common core that everyone uses, and then we have domain-specific applications. And we, from the IDS, but also from the GaiaX and from all other sites, we strive for alignments with each other so that we can finally achieve data space implementations at global scale. So yeah, thank you very much for your time. Again, my name is Johannes. And yeah, I work very closely together with Sebastian and other colleagues from IDSA to prepare today's Tech Talk. Yeah, thanks to everyone else who from on the organizational side, also Anil, for example. And yeah, thank you very much for your time, and I'm very happy to take questions.
Thank you very much, Johannes. So that was really enlightening, I would say, from my end at least, because it was, I know a lot of people are really dealing with this technical interoperability or semantic interoperability issues, and also compliance with GaiaX and IDS. And I think your presentation is a great way, a great guideline for that. So we have a question from in the list from Ioannis Chrisakis. So it says, is the information model available in any format like all, RDF, etc.?
I need to unmute myself. Yeah. Yeah. So thank you for your question. Yes, it is. We do have. Let me just move this to the other screen. So we do have a W3 ID identifier for the core information model. So it's w3id.org IDSA core. And from here, we have the documentation information on all this, and the IDS information model is available in all common serialization formats, including RDF XML, JSON LD, N-triples, and the RDF total format. So yes, it's available in multiple formats.
Perfect. We have another question.
Sorry, let me just add one more thing. And additionally, we developed the information model on GitHub. So when you go from the on the GitHub site on IDS Foundation, you have the information model. Also there, we provide all these different formats for download, use, and use in like any tools like Protégé and so on and so forth.
Perfect. Another question by Rafaela Giaffreda. When it comes to connectors, we see a similar initiative in Eclipse. What is the relationship between the two?
Not sure if I got the question right. Okay. Okay, so we have IDS connectors and we have the EDC, so the so-called Eclipse Data Space Connector. What is the relationship between these? Yeah, this is also a very good question. Thank you. To be honest, most of these initiatives go in parallel. So now we saw not too much development on the IDS connectors recently, but we saw very high drive on the EDC, that the Eclipse Data Space Connector, and most of the Fraunhofer colleagues are involved on both sides. So the relationship between these two is they both have rather the same goals. The EDC, the Eclipse Data Space Connector, has a lot of drive just recently, so there's lots of development going on in there. But the conceptual models, ideas, and solutions are included in both of these. So the ideas from the IDS connectors are included in the EDC, for example. So this is the relationship between these two. I hope that this answered the question appropriately.
So I think yes, as we got a thanks. So we don't have any other questions in the list at the moment. So I think I can go ahead with one. Johannes, you mentioned the implementations of it. So are there any best practices about the implementation of IDS Information Model? So I want to implement it, but want to check how others did it. So you showed the fintech example, for example. So are there any application scenarios collected in one place?
Yeah, thank you very much. Yes, so we do have of course, like in the, let me just, so we do have some information on this layer here, like in PDF files and instructions, but also on this declarative representation. So in the GitHub repository, let me just look up the link. So in the GitHub repository, we also provided examples for others to reuse. So this is the, so I need to look on the other screen, so don't get confused by that. So on in our GitHub repository of the IDSA, there's this information model, what we have here. And in this repository, we provide a directory called examples that includes multiple examples for example, for policies, for shackles, so for validation and extension of the IDS information model, for queries, and for validation as well. And here on this high level, we also have example files. And here there's a file for data, for example. In the turtle format here, we have example files like for a text research, for example, which includes where you can really nicely see that we reuse other vocabularies a lot. So for example, we use the DC terms, title descriptions, and the data catalog keyword, and so on and so forth. Here you can see an example on like the beginning and the end of this data set. So the data in this data set is about some data from 2001 to 2017, for example. And here we have like lots of examples here, not only for data, but also for participants, for data policies, and so on and so forth.
Thank you very much. I think this will be very much needed by the projects that are involved in this aspect.
Yeah, and yeah, as you saw, we organize most of our contents on GitHub, so we are really warmly welcome to raise issues, but also to contribute yourself. So if you find some error, of course, you can raise an issue, but you can also contribute or extend the information model via pull requests on dedicated branches.
Thank you for highlighting that. So I would have another one. So if there are not any other questions at the moment. Okay. So I want to implement IDS Information Model for a specific industry, and so it's a very high-level question, by the way. What would be the first few steps to start with? I mean, for someone who has a limited knowledge about applying the information model, and what kind of prerequisites should I have, like sector-specific vocabularies, and what else?
Yeah, thank you for the question, Anil. Yeah, I again come to this slide with the different information layers. So a very good first way to start off with would be to start on the like higher level, so the more abstract information. This would be, for example, the IDS reference architecture and other documents and visualizations that are provided. So this would be a very good point to start with, to get a very first overview about the details in the information model, and not only information model, but also other IDS assets such as the data space protocol and so on and so forth, and how they interact with each other. And regarding the prerequisites, this strongly depends on your on the role in your use case. So the domain experts, for example, they can provide their domain knowledge to the modeling experts, for example. But when you are in a role of like applying the information model, or maybe even evolving it or tailoring it to your use case, you at some point will need to get to this declarative representation. So you will need some basic understanding of the of ontologies and of vocabularies and how these are modeled. Yeah, of course, it is possible to only interact with the information model on this layer, like on the programmatic layer. So when you use the Java libraries, you can create a text resource, for example, like what we saw before in this example. You can create such resources just using Java. So you can create a Java class and append the information from there. But of course, this like model, like this understanding of the model, I would strongly recommend also to have a like have some experience here on this field, on this modeling and semantic modeling field. Yeah, especially when it comes to this idea here on the right, when you do not just use the information model, but you would like to add domain-specific information just for your application, for your use case. So you want to, yeah, take the information model and add new fields to that so you can use it.
Perfect. Thank you, Johannes. And meanwhile, we have another question from Victor Dabak. So we see many data standards for the same data, for example, carbon emissions. Is this catalog model a good way to make an easy to browse inventory for users to discover relevant data sets?
Okay, so we have, thank you much for the question. So let me just rethink the question. So there are many standards for the data for carbon emission. Yeah, I agree with that for sure. There are too many standards out there for most things. Yes. Is this catalog model a good way to make a browse inventory? Okay. Probably yes. I will just hop to this slide. So you could create a setup like this so that you list all the standards for carbon emissions, for example, and you model all of these as resources. So we have here, like we have Wall Street Truth 2019. Here you have maybe dozens, maybe even more resources that describe the individual carbon emission standards. And you could then put all of these inside a catalog, like a DCAT or IDS catalog for sure, and then add metadata to these. So because when you just use the IDS Information Model as core, you can of course only use the core fields like title, description, the time and geolocation things, the usage policies, and so on and so forth during query time. So if you like, if you now would maybe, for example, would like to filter all the standards you listed here in your catalog via some maybe some carbon emission concept like details, you would extend the information model maybe by 1 or 2 more fields, and all these data resources would then include these new fields, and then you can use these new fields in queries on the catalog. So you can query the catalog for give me all carbon emission standards that comply with the following filtering details. Like you can select a year, for example, some geolocation, like maybe only for Europe, only for South America, and so on. This is all included in the IDS, but then you can also add additional filters using this information you added in your domain-specific extension. So yes, you could create resources for standards and treat them as resources within this modeling idea. Yes. I hope that this answered the question appropriately.
Perfect. And meanwhile, I'm unmuting the attendees. So if you have any questions that you would like to ask by unmuting yourself, please raise your hand and go ahead. So I think this is not the case for the moment. Okay, so in this case, if there are no other questions, maybe Johannes, if you have any other final words or conclusive words, then maybe we can conclude it.
Yes, sure. Let's just conclude and finish early. Yeah, so I mean, I concluded some things earlier already. So yeah, interoperability is like a very important thing to achieve, not only for data spaces, but also for any communication space. And as we learned today, like just technical or syntactic interoperability is not sufficient enough, but we need semantic interoperability. This is also a thing that we just saw recently with these large language models, for example, like ChatGPT. The very strong benefits of these things is the semantics. So they can we feel like they understand things and they can act or use based on this understanding of information. So the information is there, but we interpret it, we understand it, and we can then transport and process it. And this semantic interoperability is like key and will become even more important in the near and far future. So we all need to work together. And today we saw the IDS Information Model, which is a very like a good tool to work on this. But although we implemented this information model, I will just be honest, so this is not the only tool to achieve semantic interoperability. So it plays together with many other techniques. And again, we do not want to say, okay, the IDS information model, it's the only way to do something right, but it really we can really pull all these benefits when we plug everything together and be compliant with anything else. So we have the IDS on an even more global scope. We have the IDS, we have Gaia-X, we have many other data spaces. All of these have very good conceptual approaches, and they also need to be aligned with each other to achieve a like global data space, a global infosphere, a global communication data space. Yeah. Thank you, Anil.
Thank you very much, Johannes. That was a really good and very comprehensive overview of such a tool. And so, as mentioned by Johannes, so please feel free to jump in and monitor the progress of the work in GitHub and raise issues and become part of it and contribute to it. So I think it will be more than welcome. So
yeah.
Thank you very much, everyone, for your participation, and wish you a great rest of the week. And thank you, Johannes, again for the presentation, and wish you an amazing day. Thank you.
Thank you.